Hello viewers, welcome back to Back Maths, and to this lesson we'll be looking at the reduction of set to basic form. And if you have not subscribed to this channel, kindly subscribe so that when a new video is being uploaded, you'll be the first person to be notified. Now let's get started. Now the meaning of sets in basic or simplest form. When a set is expressed in the form a square root of b or square root of b, then it is said to be in its basic form or simplest form, where b is a number that does not have a perfect square factors. So in simple, we are trying to say that if you have a square root of b or square root of b, then we can say that set is in its basic form or simplest form. Now my question is, or the question is, if you have square root of 18, can we say that this square root of 18 is in its basic form or simplest form? The answer is no, because when we look at the factors of 18, we are going to have a perfect square factor in 18. And because there is a perfect square factor in 18, it is making this set or this square root of 18 not to be in its basic form or simplest form. Now someone may ask, what is the perfect square factor? First, let's understand perfect square. When we talk of perfect square, we are talking about the result we get by multiplying a whole number by itself. The result we get by multiplying a whole number by itself is what we call a perfect square. So example, we can think of 2 times 2 is going to give us 4. Now, the 4 is the perfect square and not the 2 times 2. Because the result we are getting after multiplying the whole number 2 by itself 2 is 4, and it's the 4 that is making it a perfect square. We can think of 3 times 3, and we are getting 9. It means 9 is a perfect square. It continues, and when we multiply 4 by 4, we are getting 16. And when we multiply the whole number 4 by itself 4, we are getting 16, and 16 is the perfect square. We can continue, and we have 5 times 5, we are getting 25. And 25 is a perfect square. It is making this 25 a perfect square. And that continues to the last number we can think of. And so 6 times 6, we are going to get 36. And we can say 36 is a perfect square. 7 times 7, we are going to get 49. And we can say 49 is a perfect square. Now, if we find this perfect square in a factors of a number, then we can say they are perfect square factors. Now we take 18. The factors of 18, we can think of factors of 18. Now they are, we have 1, 2, 3, we have 6, we have 9, and 18. And these are the factors of 18. Now, why are we saying square root of 18 is not in its basic form? Now, when we look at the factors of 18, we can see a perfect square number, or we can see a number that's a perfect square. Now, when we look at the perfect squares, we have 4, 9, 16, 25, 36, 49. The factors of 18, we have 1, 2, 3, 6, 9. So it means 9 here is a perfect square. And when we look at the perfect square, we can see 9 clearly here. So it means 9 is a perfect square factor. And because we can see 9 as a perfect square factor in the factors of 18, it is making the square root of 18 not to be in its basic form or reduced or simplest form. Better still, we can think of square root of 20. Now, square root of 20, we can look at the factors of 20. Now, among the factors of 20, we have 1, 2, 4, 5, 10, and 20 itself. Now, the factors of 20, can we identify any perfect square? Now, yes, we can identify a perfect square 4. 4 is a perfect square. So it means 4 is a perfect square factor in the factors of 20. And because we can find a perfect square factor 4 in the factors of 20, it is making the square root of 20 not to be in its reduced form, simplest form, or basic form. And that is how it works. So example of set that are in its basic form or simplest form, we can think of square root of 2. Now, square root of 2 is a set in its basic form. Why? Because when we look at the factors of 2, then we can have 1 and 2. And among the perfect squares, we don't have 1 or 2 there, which means these are numbers that are not perfect squares, and then they are not based on that, we can say that square root of 2 is a number in its reduced form, because these factors of 2 are not perfect square factors. When we look at the surd 7, we can find the factors of 7. Now the factors of 7, we're going to have 1 and 7. And 1 and 7 are not perfect square factors, because 1 and 7 are not perfect numbers or perfect square numbers. And because of that, we can see square root of 7 is a surd in its reduced form or basic form. So better still, we can think of square root of 5. Yes, they are they are in their basic form. You can also think of 2 square root of 3. So these are examples of surd in their basic form. Now, having understand this, initially we said that square root of 18 is a surd not in its basic form. So which means we can express the square root of 18 for it to have its basic form or reduced form. So you move on. Now the topic or the title for reducing square root of 18 to its basic form is what we call as simplifying a surd of the form square root of m to its basic form. So we are representing square root of m for surd in that order. Now if you have square root of 18, how then do we reduce square root of 18 to its basic form? So first we have to find the factors of 18, which means factors of 18. Now the factors of 18, we can think of 1, 2, 3, 6, 9, and then 18. Now these are the factors of 18. So in reducing square root of 18 to its basic form, first we have to consider the factors of 18. Now among these factors, we have to identify the perfect squares. Now the perfect square, the only perfect square number we can identify here is 9. So that's the perfect square. If there were to be more or 2 or more perfect squares, we'd have considered the largest possible perfect square. But since there is only one perfect square here, we are going to take that one. That is the square root of 9. In our next example, we are going to explain a situation like that. So we have square root of 9. Now we take the square root of 9 and we take a number that is not a perfect square among the factors of 18. So a number that's not a perfect square among the factors of 18, we have 1, 2, 3, 6, and then we have 18 itself. So these are numbers that are not perfect squares. Now, if you have to take any of them, you have to take the number that when we multiply by the perfect square, we are going to get back our 18. And if you take 1 and 9, 1 times 9 is not going to give us 18. It's going to give us 9. And we cannot take that. And when we take 9 and 2, when we take this 9 and 2, yes, 9 times 2 is going to give us 18. And so we can say that 18 is equal to 9 times 2. So meaning 9 is a perfect square, and then a non-perfect square number is 2. That when we multiply by 9, we're going to get back 18. Now we are saying we want to simplify square root of 18, which means our square root of 18 is the same as square root of 9 times 2. Now if that happens, then in simplifying it, means square root of 18 now is going to be square root of 9. The root is going to affect the two numbers, so square root of 9 and square root of 2. Now square root of 18 now is the same thing as, now square root of 3, square root of 9 we know to be the same as 3. So when we find the square root of 9, we are going to get 3 being multiplied by square root of 2. And from the properties of surd, we say something like this: 3 times square root of 2 can be written as 3 square root of 2, which means 18 can be expressed or simplified to its basic form as 3 square root of 2. Now let's take the next example. In the next example, we can simplify square root of 128. We know square root of 128 is not in its basic form, and we have to find its basic form. So before we get it, we have to find the factors of 128. So the factors of 128, they are 1, 2, 4, we have 8, we have 16, we have 32, we have 64, and we have 128 itself. Now, these are the factors of 128. Now, among the factors of 128, we have to identify all the perfect square numbers or all the perfect squares. Now, the perfect squares, we can see that 4 is a perfect square. We can also see that 16 is a perfect square. We can see that 64 is a perfect square. Now, we take into consideration all these perfect squares and we identify the largest perfect square. And the largest perfect square here is 64. Now we take this 64, we multiply by a non-perfect square number among the factors of 128. That when we multiply by that non-perfect square number, we are going to get 128. So simply put, it means that 128 is equal to the largest perfect square number here is 64. Now 64 times what number among the factors of 28? That will give us 128. That is 2. So we multiply 2 by 64, we are going to get 128. And 2 is a non-perfect square number, which means if now we are saying we want to find square root of 128, then we should get square root of 64 times 2, which means square root of 128 is the same thing as square root of 64 times square root of 2. Now, if you are to continue, then I'm going to get square root of 128, which is equal to, now square root of 64 is known to be 8, and square root of 2 is the same thing. Now, from the properties of indices, we said if you have square root of 8 times square root of 2, then we can write it as 8 square root of 2. So 128 square root or square root of 128 is the same thing as 8 square root of 2. That is in its basic form, reduced form, or simplest form. Now the last example, how do we reduce square root of 75 to 8 basic form? First, we are going to find the factors of 75. Now the factors of 75, we have 1, we have 3, we have 5, we have 15, we have 25, and we have 75. Now, among these factors, which one of them is a perfect square? So the only perfect square here is 25. So this 25, we are going to multiply 25 by a non-perfect square number among the factors of 75. That is going to give us 75. So it means that we are saying 75 should be equal to a perfect square number. That is a perfect square 25. Now, what number multiplied by 25 is going to give us 75 among the factors of 75? And that number here is 3. So when 25 multiplies 75, we're going to get 25 multiplies 3, we are going to get 75. Now, if we are saying you want to reduce square root of 75 to its basic form, then it means there should be a square root of 25 and 3, which means square root of 75 is the same thing as square root of 25 times square root of 3. Now, square root of 75, we are going to get square root of 5 is the same. Now, sorry, square root of 25 is the same thing as 5 times square root of 3, which means square root of 75 in its basic form is now 5 square root of 3. And that's how we can reduce 75, square root of 75, to its basic form as 5 square root of 3. Now, let's look at the vice versa. If you have been given 5 square root of 3, how then do we simplify it to get square root of 75? Now, let's check the next one. And this is what it is entitled as simplifying a set of the form a square root of b as a single root c, that is square root of c. It means that in case we have a square root of b, how then do we simplify this a square root of b for it to have a single square root as c? So this is the whole idea. Remember in our last example, we said, how are we going to express 5 square root of 3 for it to have a single square root as 75? Now, the whole idea or plan is that when we have 5 square root of 3 and want to express that square root of 75, what we can do here is that we have to square the coefficient of the root sign, that is 5. You have to take square root of it, which means 5 squared is going to give us 25. So if 5 squared is giving us 25, then it implies that square root of 25 is the same thing as 5. 5 squared is giving us 25. Then it means that when I take the square root of 25, I'm going to get back 5. So simply put, when we have 5 square root of 3, then it's the same thing as square root of 25 times square root of 3. Because we know 5, this 5 to be the same as square root of 25. So in place of 5 here, I'm going to substitute square root of 25. If that is done, then we can continue with our solution as 5 square root of 3, then is equal to, now they are all under the square root sign and they are multiplying, which means you can write them as a single square root as 25 times 3. Now, if 25 multiplies 3, then we are going to get an answer of 75. There is our square root sign, we bring it, and we have 5 square root of 3, which means 5 square root of 3 can be expressed as square root of 75. Now let's take the next example. Now in the next example, we are saying that we want to express 6 square root of 5 as a single square root. So with that, we are first going to square the coefficient of the square root, that is 6, which means 6 squared is going to give us 36. So if 6 squared is giving us 36, then it implies that if I take the square root of 36, I'm going to get back 6. So in 6 square root of 5, then we are going to get, our 6 now is square root of 36. So we have square root of 36. And then this 6 is being multiplied by square root of 5. And then we are saying 6 is the same as square root of 36, which means we are going to have times square root of 5. We continue, and since they all have the same square root sign, we can write 1 square root for them, and we multiply the radicand. So when we multiply 36 by 5, we are going to get 180, and not forgetting our square root sign. Now it means 6 square root of 5 can be expressed as a single square root as square root of 180. Now let's take our last example. Now in the last example, we are saying that we want to express 13 square root of 3 as a single square root. Now if that happens, we are going to square the coefficient of the root sign, and that is going to give us 13 squared. We are going to get an answer of 169. Now if 13 squared is giving us 169, then we can say that the square root of 169 is the same thing as 13. So in 13 square root of 3, then wherever we see 13, we can substitute 169, square root of 169 there. So it means we have square root of 169. Now we have our existing square root of 3 there, so we bring it. Which means now, since they are all having the same square root sign, then we can have one bigger square root sign for them, and we multiply the radicand. Now 169 times 3, we are getting an answer of 507. So therefore 13 square root of 3 can be expressed as a single square root as 507, and this becomes our answer. So this ends to this video. Thanks for watching. Kindly like, comment, subscribe, and share. Bakumat, thinking beyond infinity. See you in our next video. It's bye bye for now.